Every year, 7 billion people step onto a train in India. They travel across a staggering 135,000 kilometers of track, making the Indian railways one of the most massive, complex transport systems on the planet. While this sprawling network unifies modern India, its design history reveals a specific British priority: the movement of raw commodities rather than the mobility of the local population. In 1830s Madras, the very first experimental tracks were industrial corridors. They were built to move granite, cotton, and tea directly from inland resource hubs to British-controlled coastal ports for export. These early lines functioned as a mechanical conveyor belt designed by the East India Company to accelerate the export of the subcontinent's wealth. To fund the rapid rail boom of the 1850s, the British used a financial structure known as the Old Guarantee System. The British Parliament offered private English companies a 5% annual return on their investment. If a railway lost money, the Indian Treasury was legally required to pay the difference to those private investors. This guaranteed capital funded the construction of massive, ornate Victorian architecture. Stations like the Victoria Terminus functioned as administrative landmarks, towering over the horse-drawn transport in the streets below. During World War II, the British military completely commandeered these tracks. Locomotives and materials were diverted to move soldiers and supplies, leaving the civilian network physically exhausted by the war's end. In 1947, India inherited a system divided into 42 separate, uncoordinated railway companies. The lack of a unified plan led to the dangerous overcrowding seen on trains during the partition of the subcontinent. Independent India began its journey with 42 disconnected and dilapidated railway systems that had been run to near failure by colonial wartime demands. Organizing this mess required a total administrative overhaul. In 1951, the government nationalized all 42 fragmented companies, merging them into a single entity, Indian Railways. Beyond the paperwork, they had to standardize the physical hardware, beginning with gauge, the precise distance between the rails. India rejected the British standard gauge in favor of a 1676mm broad gauge. Engineer W. Sims argued that the subcontinent's heavy freight loads and high-velocity winds required this wider, stable base to prevent trains from toppling. With the tracks finally unified, India began replacing colonial steam engines with domestic power, launching indigenous manufacturing units. They introduced high-speed diesel expresses like the Rajdhani in 1969, which achieved speeds of 120 kilometers per hour. Standardizing the tracks and manufacturing their own engines allowed the railway to shift from an extractive tool to a unified network that physically connected the country's immense population. To create a truly unified network, engineers had to bridge India's most difficult terrain. The 1998 Konkan Railway project was the test case, driving a 738-kilometer line through the dense rock and forests of the Western Ghats. The project required carving out 92 tunnels and building over 2,000 bridges through incredibly soft soil and constant water seepage, conditions that had previously prevented all-weather rail access in the region. In the north, engineers faced extreme altitude while building the Chenab Bridge. They constructed a massive steel arch across a Himalayan gorge to connect the Kashmir Valley to the rest of the national grid. This bridge stands 359 meters above the riverbed, surpassing the height of the Eiffel Tower. Its design tolerances allow it to withstand 266 km/h winds and magnitude 8 earthquakes. By drilling through the saturated soil of the south and spanning the mountain gorges of the north, engineers created a physical link between regions that were once geographically isolated. In 2017, the government merged the 92-year-old separate railway budget into the general central budget. This move simplified the accounting process and allowed for a significant increase in capital expenditure. This funding supported Atmanirbhar Bharat, or self-reliance. Instead of importing foreign designs, India began custom engineering high-tech systems specifically for its own network. One major development is the dedicated freight corridor. By building separate tracks capable of carrying double-stacked containers, the railway has reduced cargo transit times by roughly 50%. For passengers, the indigenous Vande Bharat Express represents a shift toward higher speeds. This self-propelled train set is designed to reach 160 km per hour, accelerating to 100 km per hour in just 52 seconds. The railway is now a driver of domestic innovation, designing and manufacturing its own semi-high-speed rolling stock for a modern economy. Moving more trains at higher speeds requires a digital safety layer. To reduce human error, India developed Kavach, an indigenous automatic train protection system. Using RFID, the system tracks every train's position. If two locomotives enter the same track section, Kavach overrides the pilot and applies the brakes automatically. It also solves visibility by projecting track signals directly onto the dashboard during dense winter fogs. Current projects are expanding this automated infrastructure further, including the new Bombay Bridge with its automated vertical lift for ships and a 508-kilometer high-speed corridor between Mumbai and Ahmedabad. Over 170 years, the Indian Railway transformed from an extractive colonial tool into a domestic system moving 1.5 billion tons of goods annually. It has become a self-sufficient network that supports the country's independent economic growth.